It's your friendly math tutor, Miss C here, and today we are solving quadratic equations that are going to result in non-real or imaginary solutions. So we're going to talk through a couple of different things today, and we're going to start with this problem. So I can look at this and with my math knowledge know that I'm going to end up with an imaginary solution. And here's how I know that. If I were to start manipulating this equation like I would to solve it, I can tell straight away that I'm going to end up with x squared on one side of my equation and a negative number on the other side. By definition, an imaginary number is the square root of a negative number. So that is how I know that my solution's not going to be real. Now, there's a couple of different ways that you could solve this type of problem. You could do what I just did here and solve this way. Or you could plug this into the quadratic formula and you're going to get the same thing. So it's your preference. I'm going to do it this way because this is a lot faster than using the quadratic formula. So let's go ahead and work through here and then I'll explain how we deal with the negative square root. So our next step is to get x by itself. So I'm square rooting both sides. When I do that, I get x left here. Since I'm the one that drew this blue square root bar, I need to remember to put a plus or minus because x squared could equal -7 by multiplying a positive and a positive together, or a negative and a negative together, right? So that's why I draw the square root bar. And now I have this, x equals plus or minus the square root of -7. We have a problem because we know in real numbers, you can't have the square root of a negative number. So we need to manipulate this a little bit. So before we do that, we need to remember one very important fact. To introduce imaginary numbers, the definition, according to Euler, okay, is that the square root of -1 equals I. So we're going to basically be substituting out the square root of -1 and replacing it with an I, and then that tells somebody who sees the solution that it's an imaginary solution. So here's how we do that. So I'm going to come over here and I'm going to say x equals plus or minus, and I'm going to factor out the square root of -1. So when I say that, to make -7, I have the square root of -1 times the square root of +7. Okay, so that's what I'm going to write here, the square root of -1 times the square root of 7. So the blue line and the purple line are equivalent. And now I'm going to do my substitution. So wherever I see the square root of -1, which is right here, I'm going to replace with what the square root of -1 equals, which is I. So x equals plus or minus I times the square root of -7. All right, and that is your solution. If you were to try to graph this, what you would notice is if I were to graph x squared plus 7 equals y, imaginary solutions do not touch the x-axis. So what you would notice is that your parabola does not pass through the x-axis in any way. Because this is not reflected, it actually sits above. So it looks like the parabola just shifted up above the x-axis. All right, let's try a more complex one that we're going to use the quadratic formula for. All right, and here's our second problem. I might try, if I were given this, it says find the roots of the quadratic function. I might think initially that I could factor this. That could be a possibility, but I'd quickly figure out that I can't make the numbers work. So then I'm going to be cued in that I need to use the quadratic formula. Before I do that, though, it's asking me to find the roots. Okay, that's typically where, for real solutions, my quadratic function passes through the x-axis. But if my solution's imaginary, they don't. And hence they're called roots instead of x-intercepts. So to do that, I have to set my equation equal to 0. So anytime I'm trying to find roots, x-intercepts zeros, you have to have y equal to 0. So I just did that. And now I'm going to go ahead and I'm going to set up for the quadratic formula. So I'm going to identify a, which is 2. So that's this number right here. I'm going to identify b, which is -8. Remember, the sign travels with these numbers. And then I'm going to identify c, which is 12. And that's this number right here. So when you do this, just as a reminder, your whole equation has to have 0 on one side, and then everything else has to be simplified on the other side to get your A, B, and C values. And then the quadratic formula, if you don't remember, I'll write it here for us, is x equals, and remember it's x equals because these typically in real solutions are x-intercepts, equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. All right, so wherever we see A, we're plugging in 2. Wherever we see B, we're plugging in negative 8. And wherever we see C, we are plugging in 12. So what we want to be really careful here with is that 8 is not a positive 8, it's a negative 8. And so we are going to want to make sure that we don't accidentally drop a negative. So I'm going to be really clear about that, and I'm going to color code this as I plug this in. So I'm going to say x equals. So I'm grabbing my purple pen. I'm going to put my first negative. Oops, I grabbed the wrong color. I'm going to put my first negative here, right? Because it's x equals negative, and now I'm substituting b in. My word, I'm just having all sorts of trouble. Okay, I'm plugging b in, which is negative 8. So you're going to notice I have a negative 8, okay, which is correct, plus or minus the square root of. Okay, this is where we want to be careful again. That whole negative 8 is being squared. Sometimes students forget to square the negative, and then you make a mistake. Minus, and then 4 is part of the equation. A is 2. And then C is 12. Okay. My color coding is not going so well because my pens are not switching super clearly when I when I click on the color. So sorry, this is getting a little slower than I'd like. Divided by 2 and then A, which is 2. Okay, so you can see where I've plugged everything in. Everything that represents A is blue. Everything that represents B is negative 8. And just a reminder, you're going to notice I plugged negative 8 in with parentheses in every single case. So if B is negative, it's really important to do that. And then C is green. All right, let's go ahead and simplify this. So x equals negative 8, which is positive 8, plus or minus the square root of negative 8 squared, which is 64, minus 4 times 2 times 12, that's 96. If you're wondering how I did that, I actually multiplied 4 and 2 together to get 8. And then I know my multiplication tables because my 4th grade teacher made us practice forever. 8 times 12 is 96. So that's how I got that. And then 2 times 2 is 4. All right. So I'm going to pop down here next, and I'm going to just simplify one level farther. 64 minus 96, that's going to be a negative number because the 96 is a bigger number and it's being subtracted. That gives me negative 32 here, all divided by 4. And so we're going to go ahead and simplify. Now, at this point, this is sometimes where I see mistakes from students. So people will be like, oh, 8 divided by 4 is 2. Fantastic. Well, it's fantastic except for the fact that it's still being divided by the root bar. So I'm going to actually leave it the way it is. And then I'm going to simplify the square root of negative 32, which, by the way, hopefully you're seeing that it's the square root of a negative number and it is imaginary. So I'm going to go ahead and write 8 plus or minus. Now, this is where we're going to come over here. So we know at a minimum, we need to factor this, and that would equal the square root of negative 1 times the square root of negative 32. Okay. But I also know that if I want to simplify my square root, which all of your teachers and professors would want you to do, there's a perfect square in 32. So I'm going to go ahead and make a factor tree. Most of us know that 4 times 8, right, gives us the square root, it gives us 32. But also that 8 is made up of square root of 4 times the square root of 2. I should say the square root of 8. So what I end up having here, right, is the square root of 4 times the square root of 4 times the square root of 2 gives me the square root of 32. What that technically is the square root of 16 times the square root of 32. Okay, you might have already known that 16 and 2 are factors of 32. And then we just drop down our -1. So I'm going to rewrite this as the square root of -1 times the square root of 16 times the square root of 2, all divided by 4. There's lots of different ways you can write this. So as long as your way is equivalent, that's fine. And then we have x equals 8 plus or minus. We know that the square root of -1 is I. So remember, we talked about that on the last problem. The definition of an imaginary number is that the square root of -1 is I. So I'm just substituting I wherever I see the square root of -1, which is right there, times the square root of 16, which is 4. And then the square root of 2 is just 2. And this is all divided by 4. So let's clean this up just a little bit and then we'll simplify. So in math, we don't usually lead with an I. We usually lead with the coefficient. So I'm going to swap this to make this 4I times the square root of 2 over 4. So what you can see is I took this and made it that. Okay, and now I'm going to simplify my denominator. And remember, I'm dividing 4 by both terms. So 8 divided by 4 is 2 plus or minus 4I divided by 4 is I times the square root of 2. And these are the imaginary roots. Remember that when you have equations with imaginary roots, they're called imaginary roots instead of x-intercepts because they don't touch the x-axis. So my parabola is going to look something like, this one is shifted some way, I'm not quite sure, but it's not going to be touching the x-axis. It's going to be above, and it's probably going to look something like this. Again, I don't know where the line of symmetry on this one is because I just solved for the roots, but its vertex is above the x-axis and none of the points touch the x-axis. All right, that is how you solve equations, either by solving the equation using just your typical order of operations, and then applying what you know about imaginary numbers to write imaginary solutions, and how you use the quadratic formula to find imaginary roots. And one last thing, if you ever have a problem and it's not asking for roots, but it's just asking you to solve, like if this said solve, you can still use the quadratic formula. That tells you what the result of any quadratic function is that's equal to 0. So as long as you end up getting one side equal to 0 and all the quadratic stuff simplified on the other side, you can use the quadratic formula. All right, that's it. If you found this video at all helpful, please like it so it shows up for other people on YouTube, and subscribe so you never miss one of these videos. Till next time, remember, you've got this.